this is part 3 of our chemistry chapter. There we go. And we left off with the checkpoint questions. A chemical bond, remember, is a strong attraction between atoms that makes them more chemically stable together than they are alone. Ionic and covalent are the two main types of chemical bonds that form between atoms. Covalent bonding is formed by sharing electrons, and covalent bonds are the strongest chemical bonds. The next question said, why does oxygen combine readily with other elements but neon does not? I'm going to go back to our picture of oxygen and neon. We have a picture somewhere in here. Well, we don't have oxygen and neon, but we have carbon and neon because oxygen is actually going to have 2 more electrons than carbon, but that still makes it only having 6 electrons in its outer energy level, whereas neon has 8. Neon has 8 electrons, and then oxygen has 6 electrons. So neon would be stable because 8 electrons satisfies the octet rule. Oxygen is not stable with 6 electrons in its outer shell, so it needs 2 more in order to be stable. Then, which kind of bond holds atoms in a water molecule together? And that is called a polar covalent bond. That is the bond between, I like this question because this is really confusing. That's the bond between the oxygen and the hydrogen atoms. Then it says, what attracts water molecules to each other? That is a hydrogen bond. And that forms between one water molecule and another water molecule. So we know that the hydrogen end is the slightly positive end, the oxygen end is the slightly negative end. So if another water molecule were to be close to the original one, it would line up with its negative oxygen end facing the hydrogen end of the first water molecule. And those dots represent what's called a hydrogen bond. It gives water a lot of really great qualities, and is the reason why living things are composed of such a high percentage of water. Now, chemical reactions. We do need to talk about these a little bit because there's no way to study the human body without understanding some chemistry. A chemical reaction is when reactants or the original substances rearrange themselves to form products that are totally different chemical substances than the reactants are. You probably heard the term metabolism. You probably heard it in relation to your body weight. Usually someone who is heavy has a slower metabolism. Someone who is thin maybe has a faster metabolism. But metabolism actually means the total of all the chemical reactions in the body. And chemical notation is used to describe complex events. So this covalent compound here is glucose, and the chemical formula means that it has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, chemically covalently bonded to each other. Energy is the capacity to perform work. There are 2 types. Kinetic is the energy of motion. Potential is stored energy. In chemicals, the stored energy is stored within chemical bonds. So, for example, since we've been talking about water, the energy stored within these covalent bonds, these polar covalent bonds between the hydrogen atoms and the oxygen, is called potential energy. Now, if those bonds break, that releases kinetic energy. Energy can't be created or destroyed, only changed form, and sometimes energy is released as heat into the atmosphere. It's not lost, but it is released as heat. Kind of like with your car, when your car burns gasoline, or um, if you have a regular car, not a electric one, the gasoline is burned and part of it is used to run your car, and then the rest of it is given off as heat. That's why your car gets hot. There are three types of chemical reactions that are important, and they are decomposition or breakdown reactions. They are synthesis reactions. Decomposition and breakdown, by the way, there's another word for that. Breakdown or catabolic, catabolism or catabolic. And then the synthesis reactions are the build-up reactions, building reactions, or we call these anabolic. And exchange reactions um, just cause atoms to change places in the chemical reaction, but nothing is broken down or built up. It's the same amount in the reactants as products. Okay, so here's a decomposition reaction. You have a chemical, some chemical, we're just going to call it chemical AB. When a compound is formed by between the atoms A and B, that's just made up. And when that compound breaks apart, it releases A plus B. That is a breakdown reaction. Hydrolysis, lysis means breakdown, so that is a type of decomposition reaction where water is added. Water is one of the reactants, and it is added to the original compound to break it apart. Um, one of the hydrogen atoms is attached to A, and then the O and the H are attached to B. And by the addition of water, it causes A and B to split apart from each other. So that is called a hydrolysis reaction. It's a decomposition or breakdown reaction using water to split the compound apart. And catabolism refers to all of the decomposition reactions within cells. Catabolism or catabolic reactions release kinetic energy. Synthesis reactions are the reverse of decomposition reactions. Now we have element A combining with element B to form compound AB. So that is a building or synthesis reaction. A larger molecule is made from smaller ones. And it's often called a dehydration synthesis or condensation reaction because the water, the hydrogen that's attached to one of the elements, and the OH that's attached to the other element is removed and used to form a water molecule. So water is given off in dehydration synthesis. We can say water is removed, and that's dehydration when you lose water. These reactions, these buildup reactions, are called anabolism. That's when new compounds are synthesized in the body. For example, when your body takes amino acids and uses those amino acids to form proteins. And anabolism requires energy. Instead of giving off energy, anabolism requires energy or uses up energy. Then you can have exchange reactions, and these are reactions where molecules just simply exchange places. They just shuffle around. So compound AB is now going to be compound AD. Compound CD is going to now be compound CB. But nothing is really broken into smaller parts, or no larger molecule is built. They just have atoms within the compounds have switched places. Reversible reactions are reactions that can go to the right or to the left. In other words, if you have this reaction, A plus forms compound AB, but compound AB can also break down back into A plus B. That's a reversible reaction. Okay, using the rules for chemical notation, write the molecular formula for glucose. That's going to be C6, 6 carbons, H12, 12 hydrogen atoms, and O6 is 6 oxygen atoms. Identify and describe 3 types of chemical reactions important to human physiology, and those are dehydration synthesis, hydrolysis, and exchange reactions. In living cells, glucose, a 6-carbon molecule, is converted into 2 3-carbon molecules. This is going to be a breakdown reaction. It's going to be what's called a hydrolysis reaction, which is a type of catabolic reaction or decomposition reaction. If the product of a reversible reaction is continuously removed, what will be the effect on the equilibrium of the reaction? So if we've got this chemical reaction where A plus B forms AB, or AB can break down and form back into A plus B. If we keep removing AB, then this reaction is going to continue forming AB. So it will remain in equilibrium. So the reaction is going to go to the right, is how we say it. All right, enzymes lower the activation energy of a chemical reaction, and that makes the chemical reaction take less time. So the activation energy is the amount of energy required to start a reaction, and it can come from changes in temperature or pH or other changes, and often these changes could be deadly to cells. So instead of temperature or pH or anything that could be deadly, cells use enzymes as catalysts to speed up chemical reactions. Enzymes lower the activation energy that is required for that chemical reaction to occur, and it eliminates the need for extreme temperature or pH changes. Enzymes are catalysts. They are protein catalysts. And the enzymes are not permanently changed, so they can be used over and over again. So this shows you a chemical reaction where here's your reactants. Typically, the reactants need this high amount of energy in order to form into products. But with an enzyme, they don't need as much energy, so the reaction occurs much faster. Enzymes lower the activation energy of the reaction. Exergonic reactions release energy, and endergonic reactions absorb energy. Our exergonic reactions are typically the catabolic reactions, the breakdown reactions, and endergonic are typically the anabolic or synthesis or buildup reactions. What is an enzyme? It is a protein catalyst. Enzymes lower the activation energy so that our cells can carry out chemical reactions much faster and without having damage. A nutrient is defined as a substance from food necessary for normal physical functions. And nutrients include carbohydrates. You may have heard these referred to as your macros. Carbohydrates, proteins, and fats. But nutrients can also include vitamins, minerals, and water, which are needed in smaller amounts than your macros, than your carbs and your proteins and your fats. Metabolites are substances involved in, or they could be the byproduct of metabolism. So they can be the substances that are built by your body or by your cells, or they can be the substances that are consumed and broken down from the food that you eat. All right, inorganic and organic. Organic, just to simplify this and make it go a little faster, you must have carbon and hydrogen, not just carbon, but carbon and hydrogen in order to call a compound organic. So again, organic must have carbon and hydrogen.